Now I'm going to explain to you the physics background of projectiles while throwing a discus. Before we start any type of equation, we need to know the background of the physics when a person throws a discus. So sine and cosine are pretty much the most important things while throwing a discus. Okay, so x is always going to equal the cosine theta. And this symbol right here represents theta. Same goes for the vertical axis. Y is equal to sine theta. Now, remembering that x equals cosine theta and y equals sine theta, now I'll explain to you sine and cosine in parametric equations. Remember, when we have a triangle, there's always a hypotenuse. And for projectiles, this hypotenuse will always equal 1. And x will be the horizontal axis, and y will equal the vertical axis. This symbol here represents this angle, and it is called theta, a Greek symbol. Many people sometimes ask, why use sine and cosine? Well, I can answer that. Okay, so we have this little guy throwing discus right here. Now, sine is always going to equal opposite over hypotenuse, hence the OH. So, if the person's standing here and it's opposite over hypotenuse, then just remember that sine is vertical, so this arrow represents opposite, so just remember opposite over hypotenuse equals sine, and sine equals the vertical. Same goes for cosine. Cosine equals adjacent over hypotenuse. Here's the adjacent, and here's the hypotenuse. Cosine is the x-axis, the horizontal axis. Before we start these equations, there are some basic terminology that you're going to need to know. First off, projectiles. It's an object that is launched, in this case, the discus. It is defined in terms of position, velocity, and acceleration. Trajectory is the path of the projectile. Theta, represented by this Greek symbol, equals the direction of the sum of the horizontal and vertical components. Now this is where we tie in cosine and sine with the vectors of a projectile. So when you throw a discus, there will be the vertical axis will equal Vy, and the horizontal axis will equal Vx. Now remember when I told you that theta equals the sum of the horizontal and vertical components, this stands true. Each line is exactly 10 units apart. And this yellow line equals V, which is also 10 lines. So, hence, the terminology is true. Vx plus Vy is equal to theta. Now, this is where it gets interesting. There are two parametric equations utilizing sine and cosine. First, we take cosine theta, and we set that equal to Vx over V. So Vx over V. Then, our final equation will equal Vx equal to V cosine theta. The same thing goes for sine. Sine theta will equal Vy over v. And then we get Vy equal to V sine theta. Here I made a sketch of a projectile in motion. So when a person throws a discus, starting about here, the projectile will begin looking like this. Then, once it reaches the max height, it stays at the same level, and then while it goes down, because of gravity, the axes flip, and then it ends just like this. Now I'm going to zoom in so you guys can take a look on your own as to what the projectile will look like in physics terminology.